Welcome to Mastering Solutions. We don't have to draw a ray diagram for these ones. We're going to use the equations to solve for the image position and the height. Let's start with the image position, and we'll use the thin lens equation, which we've used a lot, and it says that the power of the lens is equal to the inverse of the focal length in meters, and that's also equal to the inverse of the image distance plus the inverse of the object distance. So now we're trying to solve for this one. So if we minus over 1 over s, that'll give us 1 over s prime is equal to 1 over f minus 1 over s. And we're given everything, so let's plug them in. So 1 over s prime is equal to 1 over the focal length. And since it's a diverging lens, the focal length will be negative, meaning a negative powered lens for diverging. So negative 0.3 meters. And then we're going to minus 1 over the object distance, which is 60 centimeters in front of the lens. So this one will be positive. The sign conventions for these are really important. If you understand them well, you'll do amazing on these types of questions on your test. So here's 1 divided by negative 0.3 minus 1 divided by 0.6. Gives us a negative 5 diopter lens. And now the 5 diopters is in our answer because we want it in meters, of course. So we'll take the inverse of that. So we're going to have a negative 20 centimeters. So negative 5 gives us negative 0.2. So the image distance is equal to negative 20 centimeters where it'll form. Now we can move on to the image height, and we'll use magnification equation for that one. So magnification is equal to the image height over the object height, which is equal to the negative image distance over the object distance. And this section here, this is what we're going to use to solve for h prime. So if we isolate that by multiplying both sides by h, we'll now have h prime is equal to h times a negative s prime over s. And so h is given to us as 1 centimeter tall. So we have h prime is equal to 1 times 10 to the negative 2 meters, negative 2. And then negative, this is from the equation, this is from the answer. So we'll have two negatives here, which when you plug it into the calculator, of course, will be positive. But just remember that both of these negatives are important. So negative 0.2 meters, and that's divided by the object distance, which we said was 60 centimeters, so positive 0.6 meters. So we have 1 times 10 to the negative 2 multiplied by a negative 0.2 meters divided by 0.6. So we have 0.0033. So 1, 2 puts us in centimeters. So the height of the image is a positive 0.33 centimeters. So since this is positive, that tells us it's upright. And since this is negative, that tells us that it is virtual. So we have a virtual upright image that's 20 centimeters on the same side as the object. And it is 0.33 centimeters tall, meaning that since we have a diverging lens, it was minified, which is what diverging lenses do. They make things smaller.